Hey, what's up, guys? This is Chung here. So this time on 1743 restored array from adjacent pairs. Mm, so there's like an integer arrays nums that consist of n unique elements. So remember, it has to be a unique. But you have forgotten it. However, you do remember every pair of adjacent elements in nums. And you're given like adjacent pairs of size n minus 1. And So for each pair, U and V indicates that the elements, right, are adjacent to each other, but the sequence it could be different, and so which means the pairs can appear in any order. For example, right, so if we have like the array 1, 2, 3, 4, right? So we will have like three pairs for one for 1, 2, right? So it could be 2, 1 or it could be 1, 2. That it's not guaranteed. And another pair between 2 and 3, again, it could be 2, 3, and then 3 and 2. Similarly for 3 and 4, right? 3, 4, and 4, 3. So it could be any combination of this six uh, pairs. And our goal is that we just need to find the print out of the correct one of the possible arrays from given the pairs. And yeah, so here are some like constraints. Okay, so for this one, for example, this is the first one, right? I mean, we have to somehow mm, at the beginning I was trying to use the like the DFS. So uh basically I was thinking that, okay, I'll just randomly pick a starting point. For example, I would pick the 2 as a starting point, and then I'll see if I can build like a array, right? Going from the current root to all the way to the end. But the issue for that is that, let's say we pick 2. So for 2, there are like so from 2 we have two options. We can either go to 1 or we can go to 3. But 2 to 1 is not correct because, right, if we from 2 to 1, basically we're saying that, the 2 is before 1, right? But turns out that that's not the case, right? So it has to be 1 to 2. Mm. And then I was like, okay, if I can create like a dictionary, maybe I can think of like for the current one, if the next one is within the dictionary, then I can continue to do it. Otherwise, I just swap those two arrays. But then I struggled there a bit, and I came back to look at this array one more time, and then I suddenly realized that, so this array, it can be constructed in two ways. The first one is a 1, 2, 3, 4, and the second one is like 4, 3, 2, 1. So either of these two works. And then I just realized that, so we have a starting point and ending point. So for any array, right? So for any array here, it doesn't really matter the sequence, but the starting point and ending point will only have one degree uh, once if we build the JSON list, right, by looping through the pairs. Because here, uh, 1 will only have like one adjacent number, which is 2, and 4 will only have one adjacent number of 3. Besides 1 and 4, 2 and 3, they both have two adjacent numbers. And by doing that, we can easily find the starting point or the ending point of the of the original array. And once we have the starting point, the rest should be pretty straightforward, and we just need to convince us, right? By starting from the either starting point or the end point, and then also given like this kind of adjacent list, we can do a DFS or BFS to loop through all the list. Because let's say if we start from one, right? Assuming we find the starting point, which is one, from one we'll go to two because for one there's only one adjacent list, right? Which is two. That's why we have one, and then we go to two. But from two, how many adjacent nodes does two have? Two, right? So two has one and two also have three. But since one has already been visited before, that's why the next one, from two, it has to be three, right? And then from three, three also have two adjacent nodes. The first one is the two, the second one is four. Since two has already visited, and then it has to be four. And that's how we can build the array by you by two steps. First step is to find the starting point or ending point, and second one is we do a DFS. Uh, yeah, you can think of it as a DFS because actually there's only one path. There's no branch at all because each node will only have at most two nodes. And since we have already recorded the visited one, so there's only one path. So it doesn't really matter DFS or BFS. Cool. So I think we can start coding, right? And to be able to find the starting point and also to be able to do the DFS or BFS search later on, first we need to build a graph, right? So dict list, and we also need okay, let's build a graph first. So for UV, right, in adjacent pairs, so we insert U, insert V into U, and vice versa. We insert U to V. And then we'll find the starting point, right? So starting point is I'm going to have a current. So we start from none, and then for U in graph, right? We find the adjacent list has length one. That's going to be our starting point. So if the length of graph U is equal to one, the kernel will be U. When we do the break. Okay. And so now we need to do the BFS or DFS search. So we have answer equals to this one. We have scene dot set, right? So here, I mean, there are like different ways, the while loop, right? You can do the while loop. I mean, while the answer is smaller, well, the answer is not the length of answer is does not equal to the length of the adjacent pairs plus one. Then we just keep doing it, right? Because we know the answer will be the length of this one plus one. Or you can do this, or you can do the current one. It's not none, right? Then we just keep doing it. So when this one is not none, we append this one to the current, and then we add this one to this one, right? To the current, and then for the neighbors, right? For the neighbors equals the graph dot current, right? Basically, I set this one beforehand. So this one, it's basically if there's nothing else to be explored, right? And the current will be none, which means that when we reach the last node, right, the current will not will become to none, that's when we stop the while loop. Neighbor in neighbors, right? So if the neighbor not in scene, right? Then we update current to neighbor, and then in the end we return the answer, right? So like I said here, if the current one, if when it reaches to the last node, right? So there won't be a neighbor that we haven't seen before because the last node only has one neighbor, which has already been added to the answer previously. And yeah, I think that should work. If I run the code, click accept it. Yeah, so it passed. Right, so I mean for the time complexity, right, to build a graph, we have O of n time, and then for the while loop, it's just another O of n time, because here, even we have a for loop here, so this is a constant because it's 2, right? Because each node will have like at most 2 neighbors. That's how this, algorithm works. Yeah, I think that's it. I mean, I think the key point for this problem is that you just need to have to realize that in order to build this array, you have to start from either the starting point or the ending point, because there can only be one starting point and one ending point, and uh, whose length or whose adjacent node will be one for both starting point and ending point. And as long as you can find that, the rest is just like follow the path and find the final answer. Cool. I think that's pretty much I want to talk about everything I want to talk about for this problem. And yeah, thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.